Hey folks, next up we're going to look at some special properties of triangles. Specifically, we're going to look at finding area of triangles. And what I've written over here is you probably remember from geometry that the area of a triangle is 1/2 base times height. So I'm not going to do any examples of that. I'm going to look at some of the new stuff. If you have a side angle side triangle, the area is 1/2 S1 times S2 times the sine of theta, where I'm just denoting S1 is side 1, consider that to be side 1. S2 is side 2, consider that to be S2. And theta is the included angle, so theta is the included angle. And then the third thing we'll look at is if you're given a side-side-side triangle, to find its area we can use something called Herons Formula. This is Herons Formula. The area is equal to the square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C. Make sure you recognize that all that junk's under the radical sign. Where S is defined in a side-side-side situation, S is defined to be 1/2 times the quantity of A plus B plus C. So basically you'll add up the three sides of the triangle and you'll take half of that. This is called the semi-perimeter of the triangle. And so all I'm going to do is I'm just going to look at a couple of examples of how to use this formula to find area if you know side angle side, and how to use Herons Formula. So let's look at the first example I have written up here. First example, I have determined the area of this triangle. And this is triangle ABC. Angle C is 134 degrees. It looks like side B is 9 feet. Side A is 5 feet. This would be side C over here. And we want to find the area of this triangle. Well, the first thing I notice is that it's a side angle side triangle. I know the two sides and an included angle, so I'm going to use this formula here to find the area of the triangle. So all I do, folks, is I just simply write down the formula. 1/2 S1 times S2 times the sine of theta. Let's substitute in what we know. You know, it doesn't matter if you call this S1 or you call this S2. It doesn't matter. I'll call it S1. So 9 goes in for S1. That would be S2, which is 5. And theta is 134 degrees, so I have sine of 134 degrees. And quite simply, folks, I mean, it's purely just a calculator problem now. Make sure the calculator's in degree mode. Do 1/2 times 9 times 5 times sine of 134 degrees. And you'll get the area to be, I'm going to approximate it. The area is going to be approximately 16.19, and that would be square feet. So quick example, this quick example of when we have a side angle side triangle of how to use this formula to get the area of the triangle. And that's it. So we're going to look at a quick example now of how to use Herons Formula. Alright, hey, in this example I'd like to determine the area of this triangle, triangle ABC. And notice in this triangle I know the length of all three sides. So this is a side-side-side triangle. When I see it's a side-side-side triangle and I'm trying to get the area, I think Herons Formula. So in using Herons Formula, you know, what I tend to do first is I compute the semi-perimeter. Remember, this is the semi-perimeter. So I tend to compute the semi-perimeter, and here it's a 1/2 times 9 plus 11 plus 7, and if I do 1/2 times the quantity 9 plus 11 plus 7, I get 27 halves. So the semi-perimeter is 27 halves, or if you prefer the decimal, it would be 13.5. Now I'm ready to use Herons Formula. Herons Formula. A is the square root of S times S minus A times S minus B times S minus C. Remember, all that junk's under the square root. So I substitute in everything that I found, or everything that I know. So I know the semi-perimeter is 27 halves. I'll use the decimal of 13.5. So I have 13.5 times 13.5 minus A, which is 9, times 13.5 minus B, which is 11, times 13.5 minus C, which is 7. Make my square roots line just a little bit longer because all that junk's under the square root. And now, again, it's just a calculator problem. I fire up my calculator and I do the square root of this mess, and I get the area to be about 31.42 square feet. So to recap, if I have a side angle side triangle, I'm going to use this formula. If I have a side triangle, I'm going to use Herons Formula. And then when using Herons Formula, I need to determine the semi-perimeter because that's used in Herons Formula, as this example illustrated. And that's it for finding areas of triangles.